Okay, I want to go over the quiz. This was a quiz that you did for the take home. So let me show you. Hopefully my camera will cooperate. So here we'll recall that we had a disc centered at G. We were told the mass of the disc was 60 kilograms, the radius of zero point 0.4 meters, zero point 0.4. Uh, the M, the MC, the weight of C here is 20 kilograms, and the moment that's applied to it is 100 Newton meters. And so hopefully that's a little better. So the radius of gyration was 0.25 meters. Therefore, we know our I about D is 3.75 kilograms per meter squared. So we know there's a moment applied to the disc. There's no slip. That's important. We want to find the tension in the cord. All right. So if we look at, first off, we look at it as two separate entities. We look at the disk and we look at our mass C. So if we look at our disk, we know that we have a tension pulling down, a moment turning to the right, the weight of the disk, and then the reaction in the center, which we put, even though generally we don't need. And then that, of course, equals our kinetic diagram, which in this case is just I alpha. That's it. Okay. So we also then, on the other side, we have the mass of C, so our crate. And of course, that's going to be the tension up, the weight of C going down, and then that's going to equal the acceleration times the mass of C going up. All right. So how do we solve this? So we're going to develop equations for each of these objects. And so it's going to look like, so we're going to have first off, and it doesn't matter which order you go in, but first off, we're going to look at the drum. And so what I'm going to do is I'm going to sum the moment about the center equal to I alpha. Okay. And then uh, knowing also that the acceleration of C is going to equal zero point 0.4 alpha, right? Because if not slipping, then we know A equals R alpha. So we have that relationship. So that's going to actually be our first equation. That equals that. Then we have this one here, mg equals I alpha. So if we sum the moments about G based on this, what do we get? Assuming counterclockwise is positive, we get a negative tension times zero point 0.4 plus the moment that's applied equals I alpha. Okay. So if I simplify that, I get 0 0.4. Actually, this would have been, sorry about that. Yeah, this would have been like this. So I get 0 0.4 T plus M uh, minus 100. Sorry. So minus M. So and 100 is given, and that equals a negative 3.75 alpha. And so, of course, that's because this direction is clockwise, and so is the moment. All right, so we get that. So that's going to be our equation two. Okay. Then we look at our crate. What does a crate look like? Well, if we sum the forces in the y equal to ma, we get what? Tension minus mass of the crate times g equals mass of the crate times the acceleration of the crate, or T minus 20 kilograms times 9.81, and that's going to equal 20 times AC, or if we simplify, T equals 196.2 plus 8 pi. Okay. So where did this come from? Brought this down here. So what we did is we plugged in 0.4 alpha in for that. Okay. And then we simplified it. 20 times 0.4 is 8. So now we have this. So and so this is going to become our equation 3. And the nice thing is now we have what we need because we have a relationship for t in terms of alpha. We can plug that back in, and now we only have alpha. So if I write that out, what do I get? 0.4 and then times t. So using plugging basically 3 into 2, zero point 0.4, and then that's going to be what? 196.2 plus 8 alpha minus 100 equals negative 3.75 alpha. So we end up with negative 21.52 equals negative 6.95 alpha. Alpha equals 3.0964. Extra sig figs because I'm ultimately interested in tension. So I'm going to take this value and plug it back into here, right? So that essentially tension is 196.2, which would be that's the mg, right? That's just the tension if it were static. But then because it's accelerating up, it means it's going to have an additional tension due to the acceleration, and that's where we get the 8 times alpha. So plus 8 times about 3.0964. And so the final tension is just equal to about 221.0 newtons, thereabouts, depending on where you round it and whatnot. Okay, so that's it. That's the quiz. Hopefully you got it. Not too much to it. Definitely something that you might see on the final. So if you didn't, I would go back and review this, make sure you understand it. All right. Thank you.